This is a fossilized eye socket. It's the size of a dinner plate, bigger than your whole face. It belonged to an animal that swam in the prehistoric ocean, and for a long time it raised a very uncomfortable question: what kind of creature needs an eye this enormous? Because eyes are expensive. Evolution doesn't hand out giant eyes for fun. An eye this size only makes sense in a place that is cold, crushing, and almost completely dark, and it only makes sense if there's something down there worth seeing before it sees you. Hold this image in your mind. We're going to start at the surface, where the water is warm and bright and the monsters are merely terrifying. And then we're going to go down, layer by layer. And I promise you, it gets worse the deeper we go. Let's start at the top. Right at the surface, in the warm, bright, sunlit water where you'd feel safest, there was a fish that looked like it was assembled out of pure aggression. Xiphactinus. Around 18 feet long, built like a torpedo, with an underbite full of long, needle-sharp fangs and a face frozen in what can only be described as permanent rage. If you've ever seen a deep-sea fish and thought that shouldn't be that big, this was that, except it lived near the surface, and it grew to the length of a car. Xiphactinus had one strategy, and it was as simple as it was horrifying: swallow your prey whole, while it's still alive. It didn't tear chunks. It didn't chew. It opened that fanged mouth, accelerated, and engulfed entire other fish in a single gulp. And here's where it gets unforgettable, because we don't have to imagine this. We have proof. Paleontologists found a Xiphactinus fossil with another fish, a 6-foot fish, fossilized completely intact inside its stomach. This thing swallowed a 6-foot fish whole and then died. The leading theory is that its last meal was still thrashing when it went down, and it either ruptured something inside or the struggling prey killed the predator from the inside out. So this fossil is two animals at once, a predator and its final, fatal mistake, preserved together for 80 million years. A snapshot of the exact moment greed turned into a death sentence. And Xiphactinus wasn't rare. It cruised a vast, shallow sea that once split North America clean in two, a warm, sunlit highway of water called the Western Interior Seaway. That sea was absolutely packed with these things. So this wasn't some isolated freak. The brightest, warmest, most inviting water in the prehistoric world was patrolled by schools of car-length fish whose entire approach to life was open mouth, accelerate, regret nothing. If you were anything smaller than them, which was almost everything, the surface was not a place you wanted to be. Now meet an animal so strange that paleontologists nicknamed it Godzilla. Dakosaurus was a crocodile, but throw out everything you know about crocodiles, because this one had gone fully, terrifyingly aquatic. Around 15 feet long, it had flippers instead of clawed feet and a proper fish-like tail fin instead of the heavy tail of a swamp croc. It never crawled onto a riverbank. It was born, hunted, and died in the open sea. And its head is what earned it the monster name. Modern crocodiles have long, thin snouts full of identical cone-shaped teeth, perfect for snapping up fish. Dakosaurus threw that design in the trash. It had a short, deep, powerful bulldog skull, and instead of cones, its teeth were large, flat, and serrated. Serrated. Like steak knives. Like the teeth of a Tyrannosaurus. Those edges weren't for gripping slippery fish. They were for slicing chunks out of large prey, other marine reptiles, big fish, anything it could overpower. So while every other crocodile relative was politely eating fish, Dakosaurus had evolved into a deep-bodied, serrated-toothed apex predator that cut its food apart in open water. It was a crocodile that decided being a crocodile was beneath it and became a shark-shaped butcher instead. And it was patrolling the same warm, well-lit water you'd think was the safe part of this ocean. Now the light finally starts to fade and the necks start to get longer. A little deeper, where the sunlight turns hazy, something was moving that your brain genuinely struggles to accept. Picture a body the size of a small whale, for enormous flippers, and then a neck so long it almost doesn't look real. Elasmosaurus. It was about 34 feet long, and more than half of that, around 23 feet, was just neck. 72 vertebrae stacked into a living fishing rod. For a long time, people got this animal so wrong it's almost funny. The scientist who first reconstructed it put the skull on the wrong end on the tail instead of the neck, because nobody could believe a neck could possibly be that long. The real animal was even stranger than the mistake. Now, you'd assume a neck like that was for reaching down to the seafloor, or striking like a snake. But the truth is creepier. That neck was probably for stealth. Elasmosaurus likely drifted below a school of fish in the darker water and slowly raised just its small head up into the group, its huge body hidden far below in the gloom where the fish couldn't see it. The fish never saw a predator. They just saw a head. And by the time the rest of the animal registered, it was already too late. Think about what that means from the prey's point of view. You're in open water. You see a single small head approaching. There's no body. There's no threat. And then 30 feet of animal materializes out of the darkness beneath you. That's not hunting. That's a horror movie. And we're only at the second layer. Below this, the light is nearly gone, and the things waiting there don't bother with stealth at all. Deeper still, where the blue has gone almost gray, you'd meet the opposite of Elasmosaurus. No long neck. No subtlety. Just a 30-foot torpedo of muscle with a head the size of a small car. This is Kronosaurus, a pliosaur, and it was the closest thing the ocean ever made to a Tyrannosaurus rex that could swim. Its skull alone was around 9 feet long. Its teeth were the size of bananas, conical and built not for slicing but for crushing, for biting down on something hard and simply ending it. Estimates of its bite force put it among the most powerful of any marine reptile, strong enough to crush bone, shell, and armor without slowing down. It ate sharks. It ate other marine reptiles. It ate the long-necked plesiosaurs we just met. We've found plesiosaur bones with pliosaur bite marks in them. The hunters had their own hunter. And Kronosaurus moved in a way that should not be possible for something that size. For huge paddle-like flippers let it fly through the water the way a sea turtle does, but with terrifying power, capable of sudden, explosive acceleration. So you have a 30-foot animal with a 9-foot head and a bite that crushes bone, and it can ambush you with a burst of speed from the gloom. There was no out-swimming this. There was no out-armoring it. If Kronosaurus decided you were food, you were already food. And we know exactly how it ate, because some Kronosaurus fossils have been found with teeth that are broken, worn, and regrown, the kind of damage you only get from repeatedly biting into hard bodies and bone. This wasn't an animal that picked at soft fish. It was built to take the worst armored, most dangerous prey in the sea and crush it anyway. Some scientists even suspect it occasionally cannibalized smaller members of its own kind. At this depth, in this layer, there was simply no such thing as too big or too tough to be eaten. There was only Kronosaurus, and everything else. But size and bite force were about to be taken to a level that makes even Kronosaurus look modest. Because the next animal didn't just rule its layer of the ocean. It was the largest predator the seas had ever produced. Now the water is genuinely dark, and the scale of things changes completely. Meet Shastasaurus, an ichthyosaur, a fish lizard, and one of the largest marine reptiles that ever existed. The biggest estimates put it at over 60 feet long, rivaling a modern sperm whale. When you're swimming next to something the length of a blue whale in near total darkness, your sense of what's possible just breaks. But here's the twist that makes Shastasaurus so unsettling, and it's not its size. It's that this colossus had almost no teeth. Its snout was short and its jaws were nearly empty. For an animal this enormous, that seems like a mistake until you understand how it ate. Scientists think Shastasaurus was a suction feeder. It would get close to its prey, suddenly drop its lower jaw, and create a vacuum so powerful it sucks soft-bodied animals, squid and fish, straight out of the water and down its throat. No biting required. No chewing. Just a 60-foot animal inhaling its prey out of the dark. Imagine that. You're a squid, drifting in the deep, and the darkness in front of you isn't darkness, it's the open mouth of something the size of a whale, and then the water itself turns against you and pulls you in. The biggest hunter in the ancient sea didn't roar or thrash. It just inhaled. Silent, enormous, and almost impossible to see coming until the water started moving the wrong way. And think about what a body that long means at this depth. 60 feet of animal needs to dive into cold, dark water to find enough food, holding its breath the entire time. Because ichthyosaurs were air breathers, they evolved from land animals and never gave the lungs back. So Shastasaurus was making deep, dark hunting dives like a modern whale, hundreds of millions of years before whales existed, surfacing only to breathe before vanishing back down into the gloom. The largest predator in the sea was also one of the loneliest, a silent giant commuting between the light and the dark, taking whatever the deep handed it. And we're not done descending. Because past the giant reptiles, in the truly deep water, the ocean stops sending vertebrates at all and starts sending something with 10 arms. Now the sunlight is completely gone. This is the layer where pressure crushes and the cold bites, and this is where we meet Tusoteuthis, a giant squid from over 80 million years ago, with an estimated length of around 20 to 35 feet. A soft, boneless, intelligent predator the size of a bus, hanging in absolute darkness, waiting. We almost don't know it existed, and that itself is the unsettling part. Squid have no bones. When they die, they essentially dissolve. The only hard part of Tusoteuthis was a single internal structure called a gladius, a stiffening rod inside the body. So this enormous deep-sea predator is known mostly from that one part, found preserved in ancient seabeds. Everything else, the arms, the eyes, the hunting behavior, we reconstruct from a single internal blade and from comparison with the giant squid that still haunts our oceans today. And here's the detail that closes the loop on the whole dive. We found Tusoteuthis remains inside the stomachs of other predators, which tells us that even this 30-foot deep water monster was, sometimes, prey. Something was hunting the giant squid in the dark. Something that could find a soft, silent, intelligent animal in water with no light at all. Which means there was an even better hunter down there. One built specifically for the blackness. And to find it, we have to go back to where we started, to that enormous fossilized eye. Before we reach the bottom, the ocean has one more shock, and this one isn't a fanged predator. It's a turtle. But not the kind you're picturing. Archelon was a sea turtle the size of a small car, around 13 feet long and 15 feet across the flippers, weighing as much as a pickup truck. It's the largest turtle that has ever been discovered. Just sitting in the prehistoric water, slowly flapping, was a reptile bigger than your sofa, your dinner table, and most of your living room combined. What makes Archelon eerie rather than cute is what it didn't have. Unlike modern sea turtles, it didn't have a solid, heavy shell. Its shell was a skeletal frame covered in leathery skin, lighter, more flexible, built for a life spent entirely in the open ocean, possibly drifting in the dark mid-water for years at a time. We found old Archelon specimens missing limbs, healed over, suggesting some of them lived for decades and survived attacks from the very predators we've been meeting this whole dive. So picture the full scene now. You're somewhere in the dim middle of the prehistoric ocean. Around you, an 18-foot fanged fish that swallows prey whole, a 34-foot animal that's mostly neck, a 30-foot reptile that crushes bone, a 60-foot suction-feeding colossus, a 30-foot squid in the black water below, and now a leathery turtle the size of a car drifting past like it owns the place. Every single layer had a monster. And we still haven't reached the one with the giant eyes. It's time to go all the way down. Remember the eye. The fossilized socket the size of a dinner plate. It belonged to Temnodontosaurus, another ichthyosaur, around 30 feet long, and it had the largest eyes of any animal known to have ever lived. Each eye was roughly 10 inches across, the size of a dinner plate, bigger than a basketball. And now you understand the question from the beginning: what needs eyes that big? The answer is everything we just swam through. Temnodontosaurus hunted in the deep, dark water, the cold layer where sunlight doesn't reach, where Tusoteuthis and the other deep dwellers lived. And down there, the only way to hunt is to gather every last particle of light. An eye 10 inches wide is a light collecting machine. It let Temnodontosaurus see in conditions where almost nothing else could, to spot the faint shape of a squid, or the dim glow of bioluminescence, in water that to us would be pure black. It wasn't just big. It was built to own the darkness. And the eye had one more secret. Around the eyeball sat a ring of bony plates, a structure called a sclerotic ring, that braced the eye against the crushing pressure of the deep and held its shape as the animal dove. In other words, this eye wasn't an accident of size. It was engineered, plate by plate, specifically to keep working hundreds of feet down, in the cold and the black, where the pressure would warp an ordinary eye. Evolution didn't just give Temnodontosaurus big eyes. It armored them, so that the deepest, darkest layer of the ocean, the one place that should have offered some mercy, had a 30-foot hunter that could still see you perfectly. Think about what that means. Every monster on our way down was terrifying in the light, or in the dim. But the deepest, darkest layer, the one that should have been the safest because nothing could see, had a 30-foot predator with eyes evolved specifically to hunt where seeing was supposed to be impossible. There was no safe depth. There was no darkness deep enough to hide in. The prehistoric ocean had a hunter for every single layer of water, all the way down to the bottom of the light. And the deeper you went, the better the things waiting for you could see. That eye wasn't a curiosity. It was a warning, fossilized in stone, that the deep was never empty. It was just watching. That's the truth about the prehistoric ocean. It wasn't dangerous in one spot. It was dangerous at every depth, warm and bright at the surface, cold and crushing at the bottom, and stacked, layer by layer, with a different nightmare at each level. We started where it was safe and we ended in the dark with an animal built to see us coming. And every one of these creatures was real. Every one of them is gone. And the ocean that replaced them is, by comparison, almost peaceful, which should make you wonder what the next few million years might bring back. If you made it all the way down with me, you're exactly who this channel is for. Tell me in the comments which layer you'd refuse to swim through, surface, middle, or the deep. Subscribe, because next time we go somewhere even stranger. And there's another deep dive waiting for you on screen right now. I'll see you in the deep.